Hi, this is Mr. Max. So I am doing one more question on how to differentiate, in this case, a trig function. So again, just remember, if you want me to upload more of this material, please don't hesitate to make a contribution. Contact me. You reach me by the following email address. Send the details. Maybe I can help you with exam preparation and the likes. But do drop me do contact me. Good. um, this question over here also requires prior knowledge on a few things. So we have a trig function here, so again, I'm expecting that certain and if you would want me to show you how to derive trig functions, definitely I can also do that. So for example, if you have d by dx of it's the sine function, okay, that is nothing but the cosine function. So that applies similarly. Even if I was to have a constant, it will just be the same thing. If you were to do d by dx, or the derivative of the cosine function, okay, then the derivative of that is minus sine x. Again, applies the same. If you had another constant in there, it will just be like saying the same thing. Then another thing then obviously is if you have d by dx of the tangent of x, well, that is just nothing but sec square of x. Again, similarly, if you had a constant there, it would just be like that. That's the basic ones, okay? And then you build your knowledge from there as it is. Right, so just going to take that away. Expect you to do know some of this. They also arrive or appear in some formula sheet if you write an examination of some sort, but it does no harm to know how to derive them. So we have got quite a complex one over here. It looks complex anyway, but because of that complexity, we definitely have to bring in the chain rule. So what we'll do is we'll say, okay, I have d by dx of 7 multiplied by all of that, and I'll write all of that as, let me just write it again as it appears. So I have x equal 2 minus half of pi. The thing is, you have got a 7, it's like that constant that I said, constant multiple. So we can actually, it doesn't do anything. You can just actually take it out there and you can say, okay, so whatever this is going to be, it's going to be 7 multiplied by d by dx of this 10. But now I'm going to write it like so. I'm going to write it like so. Where the 4 is, I'm going to put the 4 over there. It means exactly the same thing. So let's use what we know from our chain rule. Remember our chain rule, definitely very important, or composite functions. So you have dy dx is going to be that dy and that dx, but here you can have anything. You can have dt or du. Okay, that's what we are going to use when we are using the chain rule. Okay, right, so I'm going to bring in a u substitution because I used u there. It could be t, doesn't matter. I'm going to say let u equal 10 of x over 2 minus pi over 6. And in fact, before I continue, the next one that I'm going to do, I'm going to say then let y equals to u raised to the power 4. Okay, maybe I need to just bring it down a little bit, just create a bit of space. So this is going to be y equals u to the power 4. So let's come with this one. If I have to do this one over here, if I have to do du dx, now here's where you go. The 10 was nothing but sec square of the stuff, x over 2 minus pi over 6, multiplied by the derivative of the stuff inside, which is just a half. So at the end of the day, I have a half sec square x over 2 minus pi over 6. Okay? Right. That's the du dx. Now, let's bring in dy du. That is going to be 4u cubed. There we go. And remember what was our u in the first place. So what is the chain rule saying? It's dy dx is equal to dy du multiplied by du dx. Right. So it's just a matter of combining. It's a matter of combining these for dy du with these, all of this together. But the problem is wherever u, I'm going to replace that u eventually with what I have over here. So I'm going to replace my u. So let's just combine it as this. Okay? So it's going to be dy du, which is, let's just bring in a stronger color, dy du, which is 4u cubed. There's one thing also that we shouldn't forget, right? And I'm going to put it over here. Remember the 7 that we had? Okay, the 7 that we had. So it's still going to be there. So I'm just going to say, okay, let me bring my 7 so I don't forget about it. 7. Then I have dy du, as I was saying, that is 4u cubed multiplied by all of these other ones in yellow. That's a half. That is a half. Remember, this is multiplication. Sec square x over 2 minus pi over 6. Okay? But then what was our u? So if we have to put our u back, our u was all of this stuff. That was our u. Okay? So just make sure that you copy it nicely. It's 10, blah, blah, blah. So our u is going to be 7. Then I've got 4. And again, as I was saying, our u is 10. Now that 3 is there. You can put it back there. 10, 3, what is it? X over 2 minus pi over 6. This is the u value. Multiplied by a half of sec square x over 2 minus pi over 6. Right, let's take care of the numbers, so to speak. Because this is straight up multiplication. 2 times a half of 2, this is a half of 4 is 2, 2 times that is 14. Very good. Then we have got 14, 10 cubed of x over 2 minus pi over 6 sec square x over 2 minus pi over 6. There we have our derivative. This is dy dx. Good. So applying the chain rule, knowing a little bit of how to differentiate trig functions, very handy, very handy. Step by step, do the side work, especially when things look a bit too much. You know, we definitely have to look into that. Okay. Right. Just remember, as I was saying, do provide your details so that I can see how is it that I can help you prepare for exams, and contact me at the listed email address. good luck with your study.